All right, my dudes, welcome back. We're almost there. Now we're going to get into this part that says prime. A prime number is any number with only two distinct factors, one and itself. Right on. So the easiest way I remember prime, right, is I think of my grandpa. My grandpa is this crazy old Mexican dude that says he is in his prime every day. Like my grandpa's in his prime. So he says the only person that can break him down is either himself or maybe some other dude, right? So if I have my grandpa, right, here, and he's very mean, right? And he thinks he's all that in a bag of potato chips. Really, the only buddy that can beat him, he says, according to him, is maybe himself, right? If he were to ever fight himself, and maybe some other dude, right? So another way I like to look at this is looking at prime numbers, right? The only thing that can break a prime number down, so if I have number 2, is itself and maybe some other thing right here. We don't know what this thing is yet, right? But we know that if we multiply 1 by 2, we get 2, right? So remember, a prime number can only be broken down by itself and another number, right? Perfect. And usually it's the number 1. Okay. So what are single digit prime numbers, right? So single digit prime numbers are something like 2, 3, 5, and 7, right? Examples. So now let's go over why that is, right? So the number 2, let's break it, or so number 3, let's break it down, right? Or actually, I'm sorry, let's start off with a non-example. So let's look at the number 4. Let's find out if 4 is prime. So we're going to find out, is it prime? So what two numbers can you multiply to get number 4? Well, let's look at the prime number law. It can be broken down by 4, which is itself, and the number 1, right? And it can also be broken down by 2 and the other number 2, right? So because it has two different sets of numbers, this is not prime. Let's look at the number 2. Number 2 can be broken down by itself and by 1. So 1 times 2 is 2. Can it be broken down even more? Can you get 2 times something equals 2? No, right? So this is prime. Let's look at the number 3. The number 3 can be broken down by itself and the number 1. Can it be broken down further? Can you get 2 times something equals 3? No, you can't. So this is prime. Same thing for the number 5. Same thing for the number 7. What is the only even prime number? Well, the only even prime number is 2, right? Because 2, you can only have 1 times 2. What about 4? Well, 4, we just did it. You can have 1 times 4 and 2 times 2, right? So this is number 2. Is 1 a prime number? Ooh, that is the question of the century, right? Because we can say that a prime number is a number that can be broken down by itself and the number 1. So 1 can be broken down into 1 times 1, right? And this breaks the rule because it can be broken down by itself, which is 1, and then a number 1. So the reason why we don't count 1 as a factor or as a prime number is because it doesn't have any other multiples. So if this were 2 and 2, it would make more sense, right? Because the law says is any number with only 2 distinct factors. So 2 distinct, right? Distinct means different. So here we have 3 and then we have 1 times 3. These two numbers are different, right? 2, 1 times 2. The 2 and the 1 are different. Here, you have these two are the same, so it breaks the law. So no. Because no distinct numbers or no different numbers. Right? Okay. Hopefully that made sense. So now let's get into this. The prime factorization of a number is the reduction of a number to the prime factors. Find the prime factorization of the number by using the factor tree, for example. Holy cow, that's a big definition, and I don't like it, right? So when we look at factorization, we already know what factorization is, right? Because we drew our factory, right? Our factory, boom. This is like a car factory. Please don't make fun of my drawings. We know that a factory is not just a factory, right? There are sections like an assembly plant, a design plant, right? A product testing plant. You also have a distribution area, right? And a quality check area. So it's divided into small little parts, right? That make up a big whole. So now let's get into this, the nitty gritty of this, right? So now we're going to skip this. I want you guys to use this as a reference point, but let's go on. So number 4, what is the prime factorization of 36? Right? We want to build this tree. So what is the prime factorization? So we're looking at prime numbers, right? So when we factor, we're only going to use prime numbers, right? So something times something equals 36. Let's break it down. We could say 1 times 36, but remember, 1 is not prime. So let's go to the next prime number. What about 2? 2 is prime, right? 2 times what is going to give you 36, right? So 2 times 18. Boom. This is prime. This is not, right? Because we can still break this down. So now let's break this down even further. We could do 1 times 18, but remember 1 is not a prime number, so let's do the number 2 again. 2 times 9, right? Boom. So 2 times 9, 2 is a prime number. 9 is not, right? So we can break 9 down even further into, can we do 2 again? No, because 2 times 4.5 equals 9, or 3.5 equals, 4.5 equals 9. But 4.5 is not a whole number. Remember, we only want whole numbers. So let's move up to the next prime number, which is 3. 3 times 3, yep, and that equals 9. This is a prime number, and this is a prime number. So these cannot be broken down anymore, right? So when they ask what is the prime factorization, you just give me these prime numbers, right? So I'm going to do 2 times 2 times 3 times 3, right? Awesome. So now that is your prime factorization, right? And please do not include these numbers. Do not include these numbers, right? Because these are not prime numbers, right? So another way to check yourself, or another way to cheat, basically, is if you're crunched for time and you look at this question, you're like, I don't want to do the tree. This is freaking me out. What you can actually do is look at your answers, and you should come across an answer like this, right? If you multiply these together, 2 times 2 is 4, times 3 is 12, right? Times 3 is 36. That should be a way to check yourself, right? Your prime factorization numbers should be the same as your initial number, right? So what is the sum of all the prime factors of 36, right? Well, we just got done saying this is a prime factor, 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 right? So I'm going to do 2 plus 2 is 4, 3 plus 3 is 6, and we're going to get 10, right? It's asking for the sum. Sum is adding, okay? Awesome. So what is the product of all the distinct prime factors of 36, right? So how could you better write this in an easier way, right? So distinct, remember, so when you're looking at distinct, and of course the product of it is always going to be 36, but when you're writing this out, what is the product of all distinct? So remember, they can't be the same. So if I were to write this out and I were to say 2 times 2 times 3 times 3, right? I can't do that because this is the same, and these two numbers are the same. So I have to find some way to multiply these together so that way I don't get the same numbers, right? These are your prime factorizations, but this is looking for distinct. So you can't have the same numbers, right? So what I usually do is I multiply, when they're asking for this, I multiply two different numbers. So I'm going to multiply this one by this one, and I'm going to get 6, and then I'm going to be left with 2 times 3. 2 times 3, right? This is different than this, and this is different than this, right? So these are distinct. So 6, obviously 2 times 3 is 6, and 6 times 6 is 36. I'm always going to get 36, but these are distinct, right? Remember, always look at what the question is asking. Perfect. And then let me flip over now that I'm here, and let's go over some of these, right? This will get us into imaginary numbers, and we'll actually stop here for the videos, and we'll do the rest during advisory on Monday. And Chase, I'll follow up with an email, okay? So number 1, this is going to be numbers and their imaginary friends. So how much would you like to earn in your eventual job? I'm going to say, let's do, I'm being really ambitious. I'm going to put 100,000. How much scholarship money do you want from your eventual college? I'm going to say 100,000, right? I want a $100,000 scholarship, even though I'm already out of my bachelor's degree and I'm doing my master's degree right now. But let's pretend. What is the temperature in the Bahamas right now? Ballpark it. I'm going to say like 95 degrees Fahrenheit, right? How many slices of pizza could you eat in a single sitting? I'm going to be pretty hungry this day, and I'm going to say like 7, right? This is up to you guys. This isn't really, there's no right answer for this. Unless you have some interesting ideas about money and or pizza, all of the numbers above are real. So, yeah, of course, right? $100,000, that's definitely real, right? A college scholarship, it's real. 95 degrees, it's real. 7 degrees is real, or number 7 is real, right? The only numbers that aren't real are imaginary or negative numbers under an even root, right? So basically what I can say is this is real money, right? If somebody were to hand you $100,000, that is real, right? That's something that you can feel in your hands, right? If somebody were to give you negative $100,000, that would not be real, right? There's no way that somebody could give you negative $100,000, right? That you wouldn't be able to feel that. They can take away $100,000, but they can't give you negative $100,000. Okay? So what is the square root of 1? Remember, square root is this number broken down evenly. So evenly, right? So 2 of the same numbers. So what times what? The same number is going to give you 1. So 1 times 1 is going to give you 1. Right? So what 2 numbers multiplied by themselves is going to give you this. Another one I can do is 64, right? What 2 numbers that are going to be the same times same is going to give you 64, right? Well, I know a lot of numbers that I can multiply to get 64, right? I know I can multiply 2 times 34, right? And that would give me 64, but this is not the same, this is not the same, right? We're looking for same. So I know that 8 times 8 is going to give me 64, right? So what 2 numbers that are the same are going to give you this number 1? So we know that 1 times 1 equals 1, right? What is negative 1 times negative 1? We know that a negative times a negative is going to be a positive, so that's going to be positive 1. What is negative times negative times negative? So we know that negative times a negative is going to be a positive. But what about when it's multiplied by a negative? It's going to be negative 1. What is the square root of negative 1? Holy cow. Think about that one for a second, right? So what 2 numbers, so negative 1, what 2 numbers, when you multiply them, and they have to be the same, times same, is going to give you negative 1? Well, a lot of people will say, oh, well, negative 1 times negative 1, right? So negative 1 times negative 1. This is the same, this is the same, but when you multiply two negatives, you get a positive. So 1 is not negative 1. That's weird, right? What if I do 1 times 1? 1 times 1. These are the same, but that equals 1, which is not negative 1. So this is a conundrum. This is what freaks people out. You can't get negative 1. So negative 1, the square root of negative 1 does not exist. So it does not exist. Not exists. When we say that a number does not exist, we can say that it's imaginary. So what real number could you square to get the product of negative 1? So square root, right? What real number could you square to get negative 1? And the answer is no number, right? So no number could you square to get that. So it's going to be an imaginary number. Or another way you could do this is I. That's the symbol for imaginary, which is pretty cool, right? So here's the definition. Negative 1 squared is defined as the imaginary number I. All other imaginary numbers are something multiplied by I. We'll get to this in advisory, right? Awesome. This concludes the series of videos that I promised you guys. I will be creating more videos actually after Monday, so once we get into advisory and we discuss these things. Thank you guys so much for taking time out of your busy day to actually go through these videos, okay? Bye.